Good morning, everybody. Welcome to the second class of set theory. And today we'll be talking more about sets and their operations. And as we always start with our class with a goal and a limerick, we'll do that first. So, what is the goal for today is to understand operations on groups, which are nonetheless sets, and show how it's done. Now, the limerick for today is a bit catchy and it will sure help you in understanding the concept well, the concept which I'll teach you further in this class. There once were two sets, A and B. The union said, anything goes with me. The intersection side, only shared. The complement said, what's missing is fair. So, while A minus B kept, just mine joyfully. So, according to this limerick, we will be learning more about union, intersection, complements, and the minus operator in sets itself. And you might know what minus is or subtraction is, but then in set theory, it means something different and unrelated to what we do in normal numbers and in number theory. Now, let us go through the basics of sets itself once again so that I can reintroduce the idea of Venn diagrams and continue with operations on these Venn diagrams itself. So, the one thing we need to know is that sets can be classified as numbers in brackets, right? But then we can also include different kinds of information in it. We can put alphabets, we can put emojis like I discussed in the previous class. But then when we're talking about sets, we need to represent our information to a person in front of us. Then how will we do that? Well, it won't be of much use in the future, but then it will help us get a clear idea on what we're doing currently. So here's the explanation of Venn diagrams with sets itself. So here we have A equal to A, B, C, D and B equal to 1, comma 2, comma 3, comma 4. So these are two different sets with completely different information. While A gives us the set filled with alphabets or information about alphabets, B gives us an information about four numbers, and that's 1, 2, 3, and 4. And we represent them as two circles or two different groups. One that contains the letters itself, and this is known as A, and the other one is known as B. So these are different groups or different categories that give us different information. And later on, while doing the chapter, I will be teaching you how to make these kinds of Venn diagrams. The one shown over here on the right. They are pretty simplistic and there's nothing much to it exactly. But then it'll help us know much more about abstract maths than we already know. So let us start with operations itself. So as I've shown you earlier over here, there can be many operations and the list is given over here in the table on the side. And I've also shown you the Venn diagram for it for each one of them over here. But I won't be teaching you all in just one class. I'll be only teaching you the main stuff and then build on those concepts for my further videos. So over here, what we need to know is that we have a given set A and another given set B. And we need to do some kinds of operation on it and do simple maths between these different kinds of groups. Whenever you do encryption in computers, you might have seen that they work on prime numbers and then you need unique information built within them, something that cannot be cracked. Even though they can be cracked by many hackers, but we increase the complexity of our code itself. And even the set theory doesn't have much to do with it, but then it gives us an idea on how uniqueness is important in our in our daily lives and how that each person is unique in their own ways. So first of all, we'll be going through these kinds of different operators. They're not hard and they're actually pretty easy to understand once you have given a thought about it. So let us start off with our class, shall we? Now what we'll start with is now what we'll start is with the first operation on sets, union and addition. Now hear me out over here when I say that union and addition are two completely different things. And I'll show you the catch to it in a few minutes. But first, let us get a basic understanding on what addition is. Because a lot many people confuse with the basics of addition and they don't know what it means in set theory. Let me get into the detail a bit. So let me give you two different kinds of sets. And let us start off with the simpler ones. 1, 2, and 3. Let's have another set like B, which is 4, 5, or 6. Or if you don't want that, I could also name this as any other set like A, B, or C. It doesn't matter to us. We just need a different kind of information so that I can teach you this concept properly. Now, I want to add both the information as one simple set. So let us make a set C, okay? And what this means is A plus B. I just want to add both of these sets simply. Now, what addition means in set theory is not tricky at all, but there's a confusion part which normally people make. When I say add, I don't mean adding numbers over here. Like, for example, I've made these three element wise or cardinality three wise sets over here. One is A and one is B. And for now, let us take it as ABC, B to be ABC. So what people will normally do is that they will add this. Now, as a person who knows algebra, what you might be thinking you'll be getting is A plus 1 or B plus 2 or C plus 3, which is a common error that everybody does. But in sets, we don't do that. This is wrong. What the correct answer would be, in our case, would be A, comma B, comma C, comma 1, comma 2, comma 3. Basically, we are making a bigger set that inculcates both the elements in A and also the elements in B. That's what simple addition means. And I will come to the catch later on. But hear me out very well when I say that it doesn't mean simple addition like you do in numbers. If I had the set A equal to 1, 2, 3, and B equal to 4, 5, 6, what normally people would do is 1 plus 4, 2 plus 5, and 3 plus 6. And that's wrong. And what you'll be getting from this is 5, 7, and 9. And as I said earlier, this is the wrong answer. What you will be getting if you take A equal to 1, 2, 3 and B equal to 4, 5, 6 is the simple order 1, 2, 3, 4, 5, and 6. As simple as that. No complications to it. You just don't have to add them. Simple enough. Don't add the numbers together. Just add the elements that are in B into A and create a new, set C. That's all. Just make a new set, a bigger one. Inculcate both the elements together as in one set, and that's your job done for addition. Now, union also works in a similar manner, and union is easy to understand except for the catch which I'll be telling you right now. And people also confused in that part too. Now here is the catch. Now the union operator is a U shaped thingy, and these are our two sets given to us, A union B. So it's like, so the symbol acts like anything else, like addition, subtraction, or anything else. The symbol doesn't matter to us, but what the symbol represents does. So the symbol actually represents normal addition, but the catch to it is how what we are adding and what we are merging. So for example, let me take A, okay? And let us go step by step with each of the properties we know about this set. Let us take it as 1, 2, and 3. I can convert this into a group, like a circle, just for visual representation. 1, 2, and 3. Now we can have a B set that we already have chosen to be A, B, and C. Alright? We can write this to be A, B, C. Now, now that we have done this, our next step should be doing the union operator itself. And as I said first, union operator is just like addition, but we just need to know when to do addition and when to do merging. Now, when I write A union B, I'll give you the answer right now. And you might get confused over here, but I'll show you another example on how it's actually different. So the answer would be 1, 2, 3, A, B, C. But wait, as I said earlier, this might confuse you because you're getting the same thing as you're getting for addition. Look, the same thing what we got for addition. Then how is the union operator different from an addition sign? Let me give you another example to make that clarification. Now let's think of an example A equal to 1A, A, 2, B. And let me get another one B that has the information A, 4, D, comma 2. Yeah, let's go with that. Now we need to find A union B. And let me give you the answer straight away and work it out on yourself what it is. But don't need to worry because I'll tell you what actually is happening over here in a few minutes. So the answer to this question is as simple as 1, A, 2, B, 4, D. Simple enough. But what you might be wondering is that I said you have to inculcate both the groups over here into one set. And just hold on when I ask you the question, what is A plus B? Now A plus B will be 1, A, 2, B, A, 4, D, 2. So have you seen the difference? Well, as I said earlier, the only thing over here in union is that you need to know when to add and when to merge. So over here, when you have any duplications, and when I said duplications, I mean that if you have same information given in two different sets, then what happens that when you use the union operator on both the sets, then those duplicate or same information that's in different or in these two sets will merge as one, and we are removing all duplications from our union set or union set in this case. So when you do A union B, what is being repeated or the information being repeated in both sets? A is being repeated and 2 is being repeated. So I have, so I can write over here the same set as A plus B. So it will be 1, A, 2, B, 4, D, A, 2. And what happens here is that as these are duplicating twice, I'll remove. them. Because how the union operator works is as it's in the name, uni, which means it should be only one. So it is just a unique, we need a unique set with no duplicated elements in it. So we inculcated all different types of information without any duplications of them. So we don't have any duplications or no same information being given twice by the same set. While in A plus B, we do have those duplications allowed. Because in addition, we don't have anything like uni in the name itself. And that is why duplications are allowed in A plus B if the same information is given in two or more sets. But in union, we do not allow any duplications. It's a strict must that there shouldn't be any duplications in the set where union happened. If that is clear, then let me teach you about what the Venn diagram would look like. Now, as I have said, these things merge in union. So if I have two circles right over here, with the information as I said above is 1A, 2B. And then there was a second one which has the information as A4D2. Then when I union them, then the final result that I'll get will be that these two big circles will merge together and all the common elements that are merging together as one and forming a unique combination will come in the middle in this small square. I mean, not square, like in this ellipse. And the problem with this kind of ellipse is that it actually makes sense because when you put the elements which are common in both the groups, which is A and 2 in it, then as you see, it this ring is actually sharing a space with this ring. As you have seen over here, this ring is sharing a space with this ring, and that is this space. So then this is actually giving us a complete good idea that A and 2 is a common element for or common information for both the sets. But what do we do for the rest of the uncommon ones, like 1 and B? So 1 and B are information that are only unique to A set. So if this is A and this is B, so whatever is common to A is kept with A. It's simple as that. They're not sharing and they're not caring for each other. And for B, it will just be 4 and D. It's simple as that. So if I go to the previous slide and show you this diagram over here, I've one hatched crossed it. When I say one hatched cross it, it means that it only has a unique solution to itself. And when I say unique solution, I mean there are no duplications in the elements itself. It's completely unique, no, you know, there are no any duplications within them or no reoccurrence of the same information given to us. So if you understood the concept of union and addition and the difference between them and what addition exactly means, we can go on with our next part, intersections. Intersection is what gave us the basis for union itself, which is the uniqueness of elements. We'll look into that, but for now, what I need to teach you right now is that the symbol for it is like this, an inverted U. And that the only thing that is special about intersection is finding things common between different kinds of sets or groups. So when I put an operator like this between these two different sets, it actually is finding the things that are common between these two sets. And that's the part I've colored over here. As I've said earlier, this circle part over here, I mean the elliptical part over here, is actually sharing space with both A and B, which is this and this. And that is why the result we get is this small area embedded between both A and B sets. So let me give you a clear example for this. which I've already given over here. So if A is equal to 1, 2, 3, 4, 5, and B is equal to 4, 5, 6, 7, 8, 9, which is the easiest set you can come up with right now. And if I can represent A as this group, which is just a circle with the same information over here, and B as having another group or another circle which has the same information over here, then if I use the intersection operator, my bad, the intersection operator over here, then what happens is that the common element, so we make this diagram that actually means union itself, but over here we only take out the part that is common between both A and B, which is this part. The small elliptical part is taken out, and what we get is just 4 and 5 element as the element of this set. So the result of it would be A intersection B equal to 4 comma 5. It's simple as that. And we have only colored this part because we are only taking out this part from it. Because what the intersection does is that it only takes the common parts between any of the two sets, or the common information that isn't unique within both the sets. Thank you. And if you like my video, please like it and please share it and help me spread my knowledge to every single person around the world. And help subscribe the button so you can get more videos, and press the notification button. Moreover, if you have any doubts and have any problems in any kind of question, just give me a chat in the comments below, and we'll meet you in the next video again. Have fun, and thank you very much by Utopian Engineering.